Hi guys, welcome back to another video. On the screen right now is our example for the multi-dimensional array, the one that I created before. There was a suggestion if I could do sort of a simulation of the program that I have created here. The output of the previous program is like this. If we run the code, let me show you this one here. It will ask us for the order of matrix. So let's say 3 by 3. Enter, and then we are asked to enter 9 elements here, 1 2 3 up to 9. Then press enter. We have here the given matrix, and we were able to get the sum of the trace matrix that we have here. The inquiry is maybe if I could do a simulation, the only thing that I was looking at is showing how the data are stored in this section here. Okay, so I'll be uh, going back to the codes and modifying it. Now here is our code. If you recall, we have this section here as our variables. This section here is our order of matrix, and this will be our array. Sum is used to determine later the trace matrix, and then that's it. We prompt this section here. We prompt the user to enter the order of matrix, which we will store to variables m and then n. Then we prompt the user enter m by n matrix. After that, this section here is our input. What I'm going to do here is to show how we store data into our two-dimensional array. Take note that in a two-dimensional array, there are rows and columns. Okay, so we will be storing them inside our array and then specifying its row and then column for easy retrieval of data. For me to demonstrate to you, I'll be modifying the code. So I'll be adding here, let's say, opening close curly brace, this will be a block. And then I'm going to show to you the array, the array, okay, and then the current row and then column. So not actually current row and column, since we have here our loop here. So it will be A, and then I'll display here display I, and then this one here, this will be for our J, okay, J, okay, and then semicolon. Okay, hope. So we have our array I, then J. Okay. Then here will be our scene. So let's try it out. Let's run the code again. Now we are prompted to enter the order of matrix. So let's say 3 by 3. Enter. Now as you can see here, we have here array 1 1. It means that we are going to input or store our data in row 1, column 1. So let's say we enter here 1. Enter. We are now going to store it at row 1, column 2, row 1, column 3. And then after that, since the statement here becomes false, right? Since we have here j less than or equal to n, it will move back to the top and increment I by 2. That's why we have here 2. And then since I 2 less than equal to m, we proceed here wherein the first value of j will be equal to 1. So that's why we have here 2 and then 1. Okay? So 4, 5, 6, 7, 8, 9. And then if we press enter here, we have the matrix and then the sum of the trace of matrix here. In order for us to get the sum of the trace matrix, we need to check whether the values of m and n are equal. Now, if you notice in our input here, the values of this one here, row 1, column 1, row 2, column 2, and row 3, column 3 satisfies our condition. And that is to, they should be equal, right? Now, what I'm going to do in this line is I will display now the values that equal both m and then n for reference only, okay? Let's go to this line here. Let's have our opening close curly brace. And then let's display out the value. So I'm going to display the value of I, okay, I, that's I, okay. I is equals to there. Then I'm going to display I here. And J is equals to J, okay. And the value and the stored value is what we're going to have here is our array I and then J. Okay. Then let's have an end line here. Okay, let's try this program now. Let's run the program again. We are now asked to enter the order of matrix, say a 3 by 3 matrix again. So the first value will be stored at row 1, column 1, and so on, right? So 1, 2, 3, 4, 6, 7, 8, 9. Okay. Then it will display our given matrix here. Next is, if it's a square matrix, meaning that the both rows and columns are equal, it should go into a loop and then get the sum so that we could get the sum of our trace of matrix. Otherwise, it will display not a square matrix. Since we entered here 3 by 3, so it's a square matrix, it should execute this line here. Now we added this line so that I can show you which values or values of in our array that met the condition where I and J are both equal and the value. Okay, so if I press enter here, there. Okay, so looking at our data, we have here the input. Okay, this is our input. Since it is a 3 by 3 matrix, it asks us to enter 9 elements. The given matrix is like this. So the first item here, 1, this one, number 1, is stored at row 1, column 1. 2 is at row 1, column 2, and so on. Now, since we have our condition that m and n should be equal, or not actually m and n, I and j should be equal. So here are the values that matches our condition. So we have I and j. We have here row 1, column 1, which is 1. Okay, so it matches both I and j. Then we have here row 2, column 2, which is 5. Okay, and then the last one is row 3, column 3, which is 9. And then since we have here, if we go back to our code, this section here computes for the sum of the numbers. So we store the value of uh, the numbers that equaled I. So we have here 1, 5, and 9. We compute it and store the value to sum. And then print out the given trace matrix is sum, which we have here. Okay? So here's another video, or not an actually another video. This is the explanation on how two-dimensional works and determining whether the given uh, matrix is a square matrix or not, and computing for the trace of the matrix. Okay? So I hope you like the video. Thank you for watching. Bye!